Hello students, so we will continue with the chapter where we were studying motion in one dimension, but today we will be doing motion under the action of gravity. Okay, when force of gravity is acting on the body. So write down motion under the action of gravity. Here we will be dealing with a object that is going up against the force of gravity or falling downwards due to the force of gravity. Okay, but this will be motion only in one dimension, remember. Okay, so either the body is going up, suppose the body is thrown upwards with a certain velocity from point A, so its velocity will gradually reduce because of retardation. Why? Because the force of gravity is acting in the downward direction. Hence, it will reach a certain point B, which is the maximum height reached by the body, where its velocity will become 0 at point B. After that, what happens? The body will again then start traveling back towards the ground due to the force of gravity acting in the downward direction. Isn't it? So the point to be kept in mind here is when the body is going upwards, then the force of gravity is acting downwards, that is in the opposite direction. So value of G will be negative when the body is going up, and value of G will be positive when the body is coming down, that is in the direction of gravity. Hence what will happen is when the body is going up, there will be retardation, and when the body is coming down, the body will undergo acceleration. So that is what you have to remember before we do this. And the three equations of motion we will need here. The first equation was final velocity v is equal to initial velocity u plus acceleration into time. Okay, that was the first equation we will need. Then the second equation was distance s is equal to ut plus half at square. Okay, that was the second equation. And the third equation was final velocity v square is equal to initial velocity u square plus 2 into acceleration into s, 2as, where s is the distance and a is the acceleration. So these are the three equations of motion which we will be needing here when we do motion under the action of gravity. Clear? Now let us tackle two examples. Just look at the examples I have given you. The first example was, I am rubbing this off. Okay, for us to continue I'll have to rub this, so I am rubbing this off. Hope you have noted it down. Okay, look at the question that you have. A body is dropped from the top of a tower. It acquires a velocity of something x which is not given to you. Okay, the height of the tower is given to you, which is equal to 150 meters. So you have to find the velocity at the time it strikes the ground. Okay, and that also the time taken. So let me draw it for you. There is a building here which is 150 meters in height. There is a person on top here who is dropping a stone. Suppose he is dropping a stone. Dropping means the initial velocity will be 0. And the height of the building, this height of the building is given to you as 150 meters. Okay, 150 meters is the height of the building. So the stone is being thrown from the top, dropped from the top, and it is reaching the ground. So let me mark the initial point to be point A, and the final point it reaches on the ground is point B. Okay, so initial velocity u will be 0 here, and the final velocity we have to calculate, that velocity with which it strikes the ground. That is what has to be calculated here. They have given you the height of the building. So height of the building is nothing but the distance covered by the stone as it is dropped from A to B. So distance S is known to us, that is given to us is 150 meters, okay. And the value of G they have given us here is 10 meters per second square. So acceleration due to gravity they have given us, that has to be taken as 10 meters per second square. Now let us start this question. The first part they have asked us is find the time taken to reach the bottom, and second they have asked us the velocity with which it strikes the ground. Okay, so let us find out the velocity with which it strikes the ground. For that we will use the equation number 3, just what we wrote down before. So v square is equal to u square plus 2as. Final velocity v is unknown. Initial velocity at point A was 0 because it is just being released by the person, and when it is coming down it is in the direction of gravity, so acceleration will be positive, so it will be plus 10, remember. So it becomes 2 into 10 plus 10 into s is the distance it has traveled from point A to point B, so that is nothing but the height of the building, so that I'll write as 150 meters. So v square I am getting is v square is equal to 10 into 150 is 1500 into 2 is 3000. So 3000. Therefore velocity at the point B will be equal to square root of 3000, isn't it? So let me use a calculator and find out what is root of 3000. Root of 3000 will be something like 54.7. okay. So velocity with which it is striking the ground is 54.7 meters per second. Clear? Understood? Okay. Can I rub it? I am rubbing it off. Now they have asked us the time taken to reach the ground. For that we will use the formula V is equal to U plus AT, okay. V is equal to U plus AT, and the acceleration will be taken as positive since it is coming downwards. Final velocity we have just calculated was 54.7 meters per second. Initial velocity is 0, so that is equal to, and the value of acceleration due to gravity they have given us is 10, so 10 into t. Therefore 10t is equal to 54.7. Therefore time is equal to, time t is equal to 54.7 divided by 10. I am getting is 5.47 seconds. Okay, so the first problem is complete. Now I am rubbing it off. Now look at the second problem they have given you. A ball is thrown vertically upwards with an initial velocity 49 meters per second. So this ball has been thrown upwards, okay. The ball has been thrown upwards from point A, from the ground, where its velocity was 49 meters per second. The ball is traveling upwards while the force of the gravity is acting downwards. So the ball will be suffering retardation. Hence G will be negative in this case when the ball is going up. Remember that, okay. And they have asked us to take the value of G here. In this problem they have told us G is 9.8. So that is what we will take in this equation when we are solving this problem. So the question they have asked you is find the maximum height reached and the time taken before it reaches the ground again. Okay, so when it has reached the maximum height, let me mark that point as point B. At that point, momentarily the velocity of the body will become 0, isn't it? So final velocity at the highest point is 0 at point B. Now they have told us find the height attained. Okay, so height attained will be nothing but distance, isn't it? S we have to find. So let us use the formula, the third equation, v square is equal to u square plus 2as. That is the third equation of motion we will use. Final velocity we know is 0. Initial velocity with which it has been thrown up, they have given us is 49. So 49 square. And acceleration we will take as negative, remember, okay. So 2 into, they have given us value of g is negative 9.8. So we will take it as minus 9.8 into the maximum height reached is, we don't know, that is the distance s. Okay, so 49 square is nothing but, just use your calculator, 2401, isn't it, minus 19.6 s. So if I take minus 19.6 to the other side, it will become 19.6 s is equal to 2401, isn't it? Therefore the maximum height reached, that is at point B, s will be equal to 2401 divided by 19.6. So 2401 divided by 19.6. Please use your calculator to find out. Let me also use my calculator to find out the value. 2401 divided by 19.6. Okay, so 19.6. So I am getting 122.5 meters. So the maximum height reached is 122.5 meters. So we have calculated the first part. Now we have to find the total time taken. Okay, I am rubbing this off. Sorry, okay. Now we have to find the total time it was in flight. That means from point A to B and then falling back again to Earth A again. Okay, traveling to point B and then it is falling back to Earth again. That total time I have to find. Remember, total time will be the time taken from A to B. The same time will be taken from B to A. So we will just multiply it by 2. So let us now find the time taken to travel from point A to point B. That was the maximum height. Okay, so we will use the formula v is equal to u plus at, isn't it? So final velocity we know is 0. Initial velocity they gave us was 49 meters per second, and since the body was going up, the value of g we will take as negative. So minus 9.8 into t. If I take minus 9.8 to the other side, it will become 9.8 t is equal to 49. Therefore time taken to reach the top will be equal to 49 divided by 9.8. So this is equal to 490 divided by 98. Okay, so I am getting time is 5 seconds. Is that clear? So time taken to reach from point A to the highest point B is 5 seconds. But they have asked us total time to reach the ground back again. So we have to multiply it by 2, isn't it? Because we know time taken to go from A to B is the same as the time taken to come from B to A. Therefore total time taken is equal to is equal to 2 into 5, isn't it? That is equal to 10 seconds. So it will take 10 seconds to fall back to earth again. That was the initial point. So hope it is clear to you, hope it is understood. So you can tackle more questions if I give you. Okay, I'll be giving you more questions on the same, so you will be able to understand and grasp the topic better. Okay, thank you.